Welcome to Digital Mandate, a podcast series brought to you by Tech Disruptor Media, where we unpack the real world challenges of building AI at scale. Today, I'm thrilled to be joined by Hemant Misra, a seasoned leader in applied AI with over a decade of experience driving innovation in fintech, e commerce, and analytics. Most recently, Hemant served as Senior VP and Head of Data Science at Simpl, where he spearheaded AI solution for frictionless payments. Before that, he led applied research at Swiggy as VP, transforming food delivery with machine learning, and held a senior AI leadership role at Citi. Hemant, welcome with your unique cross industry perspective from prototyping models to scaling them for millions. I'm eager to dive into today's topics. Thank you so much for joining us.
Yeah, thank you, Pranita. Thanks a lot for the introduction and the invitation. Really glad to join this forum and share my point of view with the audience.
So let's start. In the beginning, I would love to know when taking an AI system from prototypes 0 to 1 to large scale production 1 to 100, what are the most critical architectural decisions you have learned to prioritize?
So, Pranita, I'll try to give a perspective which is through experience, right? And it may be slightly different from perspective of or the way people may have acted on this. The way I looked at it, and coming from the startup, it is very important for the leaders in a startup that we are frugal, right? So typically in a startup, you do not want that the resources get wasted, right? So the strategy of deployment is to be decided at the time of prototyping itself, right? And this is slightly different from many other, places, the way they work on the thing. They may put the prototype first, and there will be certain limitation of the prototype. Let's say latency is, it's not maybe not the most important criteria. And, the things are very much settled in the sense that what is going in and what is coming out, you can see all of that. Model performance can be checked, tech metrics can be looked at, and you can do offline evaluations as well and everything. But when you go to the production, there are so many other things which could be very important, right? And if they have not been taken care at the time of the prototyping itself, it's a possibility that you may not be able to have a clear deployment. And if the patchwork is done at that point of time, it's not a very great way of solving the problem, right? So in my case, many a times the way the decisions may have been made, it is like how my landing scenario is going to look like. Do I understand the constraints of the things when they are in production? And some of the constraints are very, very, what you say, clear. That is it meeting the latency requirement, for example, right? And this latency requirement can be met by many processes. Let's say you can have a simpler model, for example, or you can say that the model has been quantized, right? It will again meet the requirement. And maybe you are having more powerful machines. And each of these decisions, they are having a cost associated with them. And this cost is something it could be, think of it that, I develop a model which is very complex and very big and everything. And it's in the prototyping is working pretty good and everything. And when I deploy it, the cost is so prohibitory that it becomes a bottleneck for me, right? So all of these decisions have to be understood beforehand. And certain decisions which do change, when you go from prototyping to production. So let's say offline validation, when you're doing your prototyping, typically you do. And I'll give you a very, what you say, concrete example. So we were developing this chatbot in Swiggy, a free text chatbot, right? And the customers are coming, and then initial things are more of if and else statement through a decision tree that the customer will say, choose the option where is my order, and let's say they go into the details and then they provide the order details. And think of it that at some point, the free text option will be provided to the customer that what is the problem you are facing, and the agent comes into the picture. Now, when we are doing the free text, obviously there are so many answers to the same question which can be there, right? Which question is more picked up by uh, the what you say customer? Those things need to be solved first. So think of it that where is my order is the problem statement, which is there. And there are so many other questions which the customer may come through. Now, first I look at my whole distribution of my data. So wherever my order, let's say, is capturing 35% of the questions which customers are asking me, then by natural choice, this becomes the first problem statement to be solved. And then there are problem statements like the customer comes and then starts having a conversation, which is a negotiation. Negotiation chatbots are not good at. Now, I have to choose my problem statement from the very first step that, okay, which is the problem I'm trying to solve? And think of it, these are all problems at the same level. Customer is coming and asking a question, which questions I should be solving for first? This is my first step, which I'll be talking about. Is the problem solvable with the existing technology which is there? Now, negotiation, chatbots cannot do, right? It's only the humans can do the negotiation. So let's say the customer is saying my order was bad and I need what you say, some money, right? A cashback or something. Now, chatbot cannot handle this because a negotiation goes on between the agent and the customer in this particular process. And negotiation, as the agent may provide a solution, the customer will say, no, I'm not happy with this solution. And we know that this cannot be solved. Chatbots are not meant for this, right? That's the place where the first decision that when you are prototyping, are you understanding that the end thing, how it needs to look like? Picking up the right problem around the many other problems which are existing even in the chatbot. Now, this is the first thing which you may have done. Now you go further, one step deeper. You look at what is the cost when this problem gets solved by you. And when I'm talking about cost, certain things I mentioned to you, right? What is the technology cost? Is it, I'm able to serve within the latency? Is my model good enough that it is having the right kind of accuracy? How much time will it take to solve this problem for the level where the deployment is possible? Now, this is the place where you start talking about, can I fail early? Because think of it, prototyping stages also encompassing, can I fail early? If I fail early, it's a possibility that I save resources for my team. Right? So some of these decisions, they are about the prototyping, but keeping in mind that the deployment is going to take place, right? Now, when you go towards deployment, so let's say you develop the system and then, it is going through the process and then agents have used it and they have given their thumbs ups and everything, and then you are going into the deployment. This is the place where, the tire touches the road, basically, and systems break down. And I'll give you a very, sweet example of this that, we developed the chatbot, which agents were like, yeah, it's working well. And then, we went into the deployment. And one of the issues which I'll mention. So we were giving the three options to our agents to select from when a free text query of the customer is coming. And if any of these three answers are good, they can select and it can go to the customer, right? And this will help that the average handling time will get reduced because agent need not type, right? And this is also about human in the loop, Pranita, if you look at it. Certain chatbots cannot be directly customer facing because we are not so sure that what is the answer which has been produced. Is it good enough, right? And agents did not, select the answers many a times. Answers are good, agents are not selecting. And that's the place where you go back to the drawing board. And what is the meaning of going to the drawing board? What's the problem statement? So we had our questions with the agents. We had our interviews with them. And agent said that your answers are so long. I'm not able to read them in the amount of time in which I need to reply back. So I'm having certain standard answers which I go through. And if you think of it, I'm giving an answer, but it is not the type of answer which the agent is expecting. Right? They are having certain mental model. And this is the place where when humans are using your system, you have to take care of them in the beginning. And we had done our interviews if you look at it. But this is when the things are in production, the agent is looking at 5 chats at one instant. They are under pressure and their behavior from natural to the when in production it changes, right? And then we had to come with the tricks. There be a small summary which is shown to the agent and they click on the summary and the answer which is there that gets provided, which could be longer, right? So these kind of things on occasion when you are in production, things will break down. Similarly, when we are putting our system together, latency, we assume that latency of 2 minutes or something will be sufficient, right? But when we put the things in production, to have that 2 minutes efficiency or latency, we realize that the kind of model which we have developed, it's too heavy. And then it was like, what are the different options we are having? And then that's the place where we were ready that if this happens, how we'll be solving it. So quantization is one methodology that your model is quantized. And if that quantization has been done, model is of a smaller size and it'll be able to do the job. Right. So these are those practical things which, whatever you may have done at the time of prototyping, you will still face them. But the key message which I'm trying to give here is that how the thing is going to land, if it is clear, the problem statements which when you are scaled and you are in production, they become lesser. But let's say you are developing more from a prototyping process only, then taking it to production is so much more difficult because all the issues which we have not thought through, you'll be facing there anyway, right? So this is what my take is, that when you are deciding your thing, even at the prototyping stage, the guardrail should be up. You should know that in production how the system is supposed to look like,
Mhm.
right? So that end-to-end thinking, Pranita, is so much important, especially in AI, because the complexity of the system is much larger.
Hmm. So following up to that question, fintech and quick commerce demands near perfect reliability. So,
Yes.
how do you ensure models stay robust while serving millions of users?
Mhm. So, see, reliability in certain ways, if you look at it, right? Just think of it. Uh, Human intelligence is not 100%,
Hmm.
right? If you ask me a question and I do not know the answer, I do not know the answer, right? But let's say I can give a general answer to it.
Hmm.
Similar is the situation for AI on many occasions.
Hmm.
AI models or ML models, let's say when we talk about, right, they have been trained under certain scenarios,
Hmm.
right? And that scenarios are the one which are providing the, let's say, reliability to you, right?
Hmm.
Now, when you go beyond the scenarios, the reliability on occasion could be constrained,
Hmm.
right? And this is the place where MLOps, for example, may
Hmm.
come into the picture. Your model is there,
Yeah.
everything is running well,
Hmm.
and one day something goes wrong,
Hmm.
right? But how will you come to know that something is going wrong? And that's the place where MLOps, or think of it, what is MLOps? You're looking at, is there a input feature changes which are happening? Is there a drift in the model, right? In certain ways that the outputs, they are not of the kind which were usually expected.
Hmm.
And when you look at all of this, this is something which is one of the keys for us to understand the reliability when it is in production.
Hmm.
Now, whatever is being done and tried and done in what you say at the time of development, certain things may happen,
Hmm.
right? And when they happen, you have to take care. That's the place where, if you really look at it, the rollback mechanisms, for example, in MLOps, right? That what was the previous model? Was it more stable in this scenario? Because think of it that I changed the model. I went to a new version. It
Hmm.
has been tested in the scenarios which were I was mentioning, right, in the constraint space. And when it was put, there are certain things which happened which we are not able to take care, right?
Hmm.
And model has gone bad, and the outputs are bad.
Hmm.
Rollback mechanism is a pretty standard thing which many a times gets followed, right? But at the same time, the important thing which we try at the time of development itself, try to catch as many scenarios as possible,
Hmm.
because more scenarios you have got, better it is, right? Again, if I try to give an example, think of it that uh, LLMs, all of us are aware through ChatGPT, right? Hallucination happens,
Hmm.
but then you try to put certain things in place, certain guardrails, that
Hmm.
hallucination does not happen. Similarly, jailbreak still happens despite all the technology development, right? So you learn from your mistake now. So the model is there. There are certain mistakes it does in production. Now, these mistakes are the one which help us understand where the things are breaking. And the next version, when we are developing, that's where these inputs go, right? So model development is a step-by-step process, right? Now, a crucial thing which Pranita many a times is under the hood, explainability part, right? Because if think of it, is model is getting used as a black box, or there is some explainability. And I am always in favor that let's try to have some explainability, if not all. And obviously, the model could be complex that we cannot have the complete explainability. Now, this explainability is another factor which helps us. Because if explainability is there, I can understand why the model is breaking. And then I can rope in that explainability part to make it sure that my model is better, right? So reliability is something which is not a one stroke. It's a continuous process, right? Certain things we take care when the first model gets built. And first model typically, if I have to give an advice to the young folks who are there, the first model should be a simpler, explainable model so that we can understand what's going on and then move towards the more complex model. And simple model may have not the kind of performance which you are looking. Let's say you desire 90% accuracy, and the simpler model is, let's say, operating at 75. But explainability helps you move forward, and then you may move towards a complex model where the performance may go up, but the explainability goes down. But the explainability which you have derived out of the simpler model, that helps build resilience and maybe gives you some understanding how the things need to be taken care of when the complex model breaks down, right? And then there are frameworks like SHAP, right? This line through which you try to think of it, understand the model in some better fashion, explainability part of it, right? And all of these are the tricks which are in the books, and you have to apply them at the time of deployment. And certain things which you may have the best model and everything. If we go to the previous answer, which was providing you on the production side, people may not use your model, not because your model is bad, but maybe the way it has been, shown. And you need to be very much aware because end-to-end thinking, Pranita, that's the deal. You have developed the model, but the end user is happy with it. That's the key business metric which you want to have. Because technical metrics you may have met, and that's the place where you need more understanding of the user behavior as well, right? So many times people feel that AI, means it solves the whole problem. No, there is engineering, then there are UI, UX, which all of this plays a major role, right? And that's what I was just, in the first question when I was answering end-to-end thinking. I cannot leave things to chances that I did a great job and then finally, the things. And sometimes think on the UI, so it could be so simple. So think of it that when we were developing this chatbot, right? Let's say the agent clicked on one of the things, right? One of them, and then realized that no, this is not a good answer. I want to change it. Now, if agent tries to erase the whole thing, it'll take time. Can I provide a button, right? Which just across and then the whole thing goes off. Now, why it is important? Because agents will start having reluctance to use the outputs provided by me in case they feel that, this simple feature does not exist. Right? And then we will be talking about, oh, the model is not reliable, or model was not working well, or it was not used. Engineering plays a major role, right? So AI folks, on many occasions, they have to sit with the product people. They have to sit with the engineering folks, right? That how their model will be deployed. And that is an important thing. GPT-3 existed, right? But it was in the what you say with the only the data science or somebody, these people were using. When the chat GPT came, which is a simple interface if you look at it, and everybody's using it, right? So us interface can make a difference, and every AI practitioner has to be aware that end-to-end is the deal.
I do agree with it. I think if I recall my conversations with some of the very prominent CIOs, just few months back as well, there was a lot of conversations happening around AI, and the problem that they were facing was similar to that. Like how to not just implement AI for the sake of it, but if
Mhm,
they are going to a CEO of their board, how they're going to explain this is the technology that they want to implement.
mhm.
But if that technology is not there and if not understood by the user who's going to use it, then
Yes,
there's no point to it.
exactly, exactly. So many people, Pranita, if you look at it, right? They see always when you are developing or I am developing something,
Hmm.
you have to have target audience in mind,
Hmm.
right? That target audience is very important for the AI folks as well.
Hmm.
We cannot be in silos and developing a high technology, because that's not how AI will ever, move on.
Hmm.
And if this is not understood, then the other reliability is what? Reliability is, let's say, your acceptance by the end user, right? You may have tech reliability of 90%, but the
Hmm.
users are not accepting it. Now, why my users are not accepting? Maybe they, let's say the kind of category of users with whom I'm dealing, they are youngsters. They do not see, let's say, the SMS which are being sent by me. Very, very, another example, this is from the Simple framework. And I did not know some of these things. That's why AI people have to be very generalistic. And I did not know that youngsters do not see SMS nowadays. I'm a person who has, grown with the cell phone. So SMS was always seen by WhatsApp came much later, right? Now think of it in simple, to remind the people that their bills are due, SMS
Hmm.
will be sent,
Hmm.
right? Now, the youngsters are not looking at it.
Hmm.
I'm wasting money using a great AI technology, and what is the great AI technology is that what is the highest likelihood that if I send you the SMS that you will have it'll get delivered to you and you will be in the right frame of mind, you will click at it and then you'll see it, right?
Hmm.
I'm doing a lot of data science
Hmm.
in terms of when this message should be delivered, what should be the type of the message, for example. Let's say, should I be saying, please make the payment, or should it be some other kind of language which should be embedded because I have already sent three messages? Now the message is going, but the person is not reading it.
Hmm.
I'm wasting my resources. It's a beautiful system which is operating there, but the overall effect of the system is poor. And that's the place where we started playing with the things and then we started realizing. And this was, it was a conversation when I was sitting with, my colleagues during the lunch, right? And this is something which I was saying, that practical part of the things. And during that time, they said that, we do not look at the SMS nowadays. And I was like, I'm sure this is not the way. And then I checked with three more folks, of the similar age group. And they said, no, we don't check. Then we devised a strategy that, these people are WhatsApp people. Now, there is a factor that who will check the message, who will not check the message. And that feedback is something which once we got hold of it. Otherwise, beautiful technologies, but not landing anywhere,
Hmm.
right? And then everything gets built on this. Your AI system is not good. It is not delivering the results which it promised. But the point is, there is a pipeline and there is a human at the end. And if that is not happening, so
Yeah.
so understanding your customer, uh, engineers do it, product people do it, AI folks have to do it.
Yes. So basically, reverse engineering it.
Yes. And
Yes.
that's why AI cannot work in isolation, Pranita.
Yeah.
And many a times engineers may not be understanding AI.
Hmm.
So the heavy lifting has to be done by the AI folks.
Hmm.
They have to put the things, in some fashion, right?
Hmm.
They have to dial down and come to that level, that what kind of implementation they are looking at.
Hmm.
What exactly is the way the product people should look at this implementation?
Hmm.
Because you cannot say that my audience should be as AI savvy as I am.
Hmm.
That's where the ball gets dropped. That's where many of the POCs, they do not reach the end. And that's the place where you have to be aware and make the right moves
Hmm.
when you are going into the POC itself. Because if your counterparts are not ready, they will not take the kill. See, you
Hmm.
cannot force anything on anybody,
Hmm.
right?
Yeah.
They have to be receptive of it. And if they see the value, they will be receptive.
Hmm.
Now, these are those soft skills, Pranita.
Hmm.
AI folks have to develop soft skills as well. This is one of the message which I want to send to the podcast. Just
Sure.
don't be AI person who is sitting in silos doing very deep work or something.
Hmm.
Be having that engineering mindset as well, that I have to make the system work end to end.
Hmm.
Right? So reliability part I talked a bit, right?
Yeah.
But this reliability is more of a tech reliability in those, but it's several other aspects of reliability. So that's why I thought let me cover all of that.
No issues. That was a very elaborate answer, and I do thank you for that. Coming to the next question, can you share a specific example where scaling an AI system surfaced unexpected technical challenge, and how did you resolve that?
Right. So many times I'm falling to the same example because this was one of the most complex problem statements we may have tried to solve. Chatbot is something which, and in the Indian scenario, it gets more tricky.
Hmm.
There were two reasons for it. One reason is that people may not use English.
Yes.
And even if they use English, it may not be the English which let's say, the AI models have been trained on. So let's say
Hmm.
BERT, which is one of the, a transformer-based architecture thing. It's a very powerful model. This transformers are the basis for, the Gen AI things, which LLMs and everything. So this BERT has not been trained on that kind of data, right? So we have to train the data on this kind of English,
Hmm.
model on this kind of English. This is one.
Hmm.
Second thing is vocabulary of food could be very different, right?
Hmm.
The way the people may ask, right, मेरा खाना कहाँ है? Code mix, right? Now, how Bert will react to it, it's anybody's guess, right? You have to look at all of these possibilities. So in the beginning, we used Bert and we thought that there are many ways to solve a problem, Pranita, typically in AI space as well, right? So we thought that we will solve the problem like a intent classification problem in chatbot.
Hmm.
What is intent classification? The person says, मेरा खाना कहाँ है? Person says, where is my food? मेरा खाना क्यों नहीं आया? मेरा food क्यों नहीं
Hmm.
आया? All these varieties, single intent is there. The person is saying, where is my food?
Yeah.
Right? So let's try to solve it as an intent classification problem, right?
Hmm.
So this was the first thing in our mind, and we tried to put the system with that.
Hmm.
We moved little, into the space, and we were having reasonably good success in many of the, what you say, dispositions. Dispositions are why people connect with us, right?
Hmm.
And then there were certain places where we started seeing the limitation of this kind of model. What's the limitation? The person says during the conversation, cancel my order.
Hmm.
Now we are having a disposition which is like cancel my order, right?
Hmm.
But the problem is that the person is not saying cancel my order. He is still stuck in his thought process. My food has not been delivered on time. That's why I cancel my order.
Hmm.
And now how should I deal with it? As a human, this dealing is very easy.
Yeah.
We'll try to console the person and then they will say, we'll give you a coupon and, all of this can be done. And we started seeing that this way of dealing with, intent classification way of looking at this thing, developing a chatbot will be very, very tricky. It'll be very fragile. It can break very easily, right? And we did not foresee when we started putting the process together. And
Hmm.
then we had to change the track. The track which we chose was, think of it, what customer is asking today.
Hmm.
Similar questions have been asked by thousands and thousands of customers in the past, right? My agents may have supplied answers to these questions in the past. So I'm
Hmm.
having all this information or data available to me.
Hmm.
Can I try to figure it out when a new question comes?
Hmm.
Out of these questions which the customer may have asked in the past, which question it is,
Hmm.
without even understanding what is the intent of it,
Hmm.
right? Now, this is what we are going into this information retrieval framework.
Mm,
Information retrieval is more about, can I understand out of these 20 patterns which is there, this new thing which has come, which pattern it belongs to.
mm,
And I don't want to worry about what this pattern exactly is, right? So think of it, I give you thousands of cats, pictures of thousands of cats, right? Thousands of dogs, and new picture comes. And you have to say it belongs to group A or group B,
mm,
as compared to you saying that it's a cat.
mm,
And it solves my problem because if I can understand what is the question,
mm,
answers which were provided by the agents previously, they are available to me. And I can use one of those answers and provide it to the customer,
mm,
right? This is information retrieval framework.
mm,
This framework is a more logical way of solving this problem because I do not have to do any intent classification now. I just have to recognize patterns and map it with the pattern which is already there in my database, right? There's more complexity. I'm just taking it away. And think of it that this scalability is not an issue. There could be millions of patterns. Cat could be there, dog could be there, elephant could be there, zebra could be there. I don't care.
mm,
Give me millions of things. I will be knowing what are these patterns. And these patterns, if I'm able to recognize, I know what is the answer to this particular question, right? As I said, I'm simplifying it, at 100 feet level. But think of it, you change the problem statement and problem statement gets more solvable, right?
mm,
This is what is, I'll say here is that on occasion, you may have multiple options in front of you,
mm,
right, to solve a problem. And I had mentioned this statement earlier, fail fast. Fail fast is the methodology for you to block certain solutions or so that think of it, I will waste less time in solving the problem through a method which may
mm,
not be very promising, right?
mm,
So as soon as, we started experimenting and it was, a quick experiments, which is the better way of dealing with the situation. And we realized that this is something which is going to hit a bottleneck very soon, right? And then we switched to the other side. Now think of it today, many of these things may be readily available
mm,
or people to take a, call how to go about solving this problem.
mm,
5 years back or something, these things were to be experimented, right? So when you have to experiment, failing fast is one of the best methods.
mm,
You remove the things which you know that they will not let you go to reach the problems, solve the problem statement, and then you are left with the technologies where you invest more time. And then think of it today, if you want to solve the same problem, maybe GPT kind of thing is another way of solving the problem, and maybe it is a simpler and a more elegant of solving this problem. So on occasion you develop a system and then cannibalism is something which is not the human cannibalism but self cannibalism of your own system is something which you need to look at because the newer technologies which are coming in the time you have to be open towards them as well. You
mm,
may have developed a system, it may be very close to your heart, but you keep reinventing. And when you do this reinvention over a period of time, what happens? Your systems, they start become more and more reliable and robust because they're using the latest technology. So think of it in many, many of our systems. We may start from somewhere.
mm,
By failing fast, we reach at a particular place and it could be stable for some duration. But because the technology is changing very fast, again, we have to reinvent ourselves, right? And the new scaling challenges and everything may come up, and then you have to move with that, right?
mm,
So this is the way you look at the things, and there are always one factor which will be important, keeping costs in mind,
mm,
whether it's a startup or whether it's another system, right? Even if you have loads of money, being frugal is an important part of this, developing the system. And on occasion, one very important factor which in certain places I have mentioned, let's say a simpler technology which is very cost efficient is giving you 80% accuracy.
mm,
And there is another very complex technology or something which is giving you 82% accuracy. You have to do your benchmark. And these benchmark are not the technical benchmark now, they are coming from the business.
mm,
How much money have you put to put this technology now? Is it solving this 2% difference? Is it meaningful in terms of business impact? Is the ROI justified or not? Right. So many a times, many decisions, Pranita, though the question is more about, scalability and where you hit the problem. But these are the other problems we need to be aware about.
Hmm.
Because think of it, I cannot develop a beautiful system which is so expensive, right, that my organization cannot afford it.
Hmm.
And believe me, means I have heard of stories over stories, across the board where people were experiment with something and, um, a few $1,000s got lost in a couple of hours because, uh, let's say you are running something on AWS and it's a cloud, right? And
Yeah.
a person comes and, runs a model, and this model is something which is still a prototype or something. It's a very expensive model. And
Hmm.
this money is lost. So you
Hmm.
need to be very careful that, so this is another aspect that when you are trying to say scalability, when you are trying to look at ROI, you are again tying back to the same thing, that is everything which is important being met? Because your models can fail just because you did not provide the right, the value is not coming out of that model, right? And these are those tricks, Pranita, if you look at it.
This
Some
reminds
of this
me.
are technical, some is not technical.
Yeah, yeah. Because I think when you were talking about the chatbot, it reminded me of that incident that happened with MACD as well.
Mhm,
Yeah, so because the language was same, even
mhm,
though we do have so many languages,
mhm,
that same language which is English, but because of accents, how each and every region pronounce same word differently,
mhm,
the entire project was cancelled out because the
mhm,
AI or the chatbot that they were using, it
mhm,
could not interpret what was said. Orders were wrong, and people were just having fun with it. So,
mhm,
because it was not able to do its job, even
mhm,
though people were having fun with it,
mhm,
Magdi still had to scrap the entire project.
mhm,
So, when you were talking about the money, it does, bring out the question how much, R&D is enough, and how much money you're willing to lose in case this doesn't happen.
mhm,
Yeah.
mhm. So, uh, is it a question, Pranita, or it's just you are wondering about it?
No, no, it was just like part of the conversation, not
Okay, okay. Because
good.
if it's a question, it's still, the main thing, this is the place where, Pranita, think of it that each of these AI thing which is there,
Hmm.
classical ML, which is linear regression, for example, one of the simplest model, right?
Hmm.
And then there are some, let's say the tree-based models, which are somewhere in between, XGBoost and these kind of things. And then you are having, the top ends, which is like BERT and talking about OpenAI, different models which are there, like GPT-3 and 4.
Hmm.
Now, putting all these things together, if you look at it, everything is having a cost associated with it, right?
Hmm.
These are all tools. An AI engineer or an AI scientist cannot marry a tool. They have to be aware of all the tools and they have to pick the right tool for the right problem statement. Because if many a times, many youngsters, Pranita, and this is something which, I've seen on and on again and again, that the fancier things get picked up.
Hmm.
So everybody wants to work on LLM. Everybody wants to, let's say use RAG, or everybody wants to say agents. But the point is it needed? If it is not needed and you are using it, you are a bad AI engineer.
Hmm.
That's the way I define it, right? Every tool is there, and then as an expert, you can come and help me understand which is the right tool to be used to solve this problem in an elegant fashion with the cost effectiveness. Because see, the I can land something on moon, maybe spending billions of dollars, or I can be ISRO, right? Frugality. And in the long run, who will survive? The one who is frugal from the beginning, from the first day,
Hmm.
because AI is expensive, right?
Yeah.
And if it is an expensive tool, you have to be very careful with it.
Hmm.
And if you are careful from the beginning, the point is you are the winner in the end.
Hmm.
So many companies, means I cannot name because, means it's more like why should I, think about the failures, because from failures we learn as well. But so many companies, they may have been this AI first in their
Mm,
mindset, right? But they were developing very expensive tools,
mm,
and they were not able to justify, right?
mm,
And some of them are very, what you say, they are, they were the best in the game. That ROI justification, if you really look at it from the AI perspective, this is still a game. Most of the people are not able to think from that perspective. And that's why AI folks, if they are working in isolation, they're not doing a good job.
mm,
They have to be well integrated. They have to understand the business ROI. They have to think of end to end.
mm,
If they are doing all of this, they are good. If they choose the right tool for solving the right problem, they are good.
mm. Right. So coming to my next question, as you mentioned MLOps. So
Mhm.
what role do MLOps and continuous integration or deployment pipelines play in your AI, productization strategy?
So, in certain places, Pranita, these tools are extremely useful. In
Mm,
certain places, they play little lesser role. And where
mm,
they are very useful, I'll just tell you, where
mm,
there is a lot of changes which are happening, MLOps makes a big difference. Because think of it, let's every month I'm rolling out a new one,
mm,
and I have to keep track of what are the features which are being used, right?
mm,
So this is more on the feature side, that tracking, the feature part. Then you have to track what were the metadata and all the, the different architecture which you may have used in the model. Then you
mm,
may have to track the model itself. Then you have to track the outputs. All of these being put together, if I'm deploying model every month, a new
mm,
version one, version two, version three, or it becomes so much more important that MLOps is part of the game. Because without this MLOps, very soon we may be all over the place. We may stop understanding what may have made what difference at what point of time. Is this
mm,
feature was good? Was this model better? Yeah.
mm,
So when you are having in that fast track, basically where models are getting trained very fast, right? ML ops is extremely important. Now, ML ops plays another role as well. Let's say the
mm,
data drift and those kind of things.
mm,
This part is important everywhere. Everywhere in the sense, even if it is a slow moving system, means slow moving system in the sense a system which is to be trained, let's say, once every 6 months versus a system which is to be trained once every 1 month. Uh,
mm,
this part is something which is important because drift can happen with every model. And drift can happen because just think of it. In a fintech space, uh, the people's choices may change,
mm,
right? In the food space, people may change their choice, for example, right? Because these are those things which are ever changing, right? And my model has to stop, start understanding if a drift is happening, and then I have to train. Similarly, fraud as a system, if you look at it, right? The new fraud methodologies, they keep popping up, and then you have to keep understanding, and how I should keep track of the things.
mm,
So MLOps on the drift side or on the the input side being changed in a big fashion, it's very critical. And in many of my cases, MLOps may have played a role in just think in I'm developing a speech recognition engine, right?
mm,
And this speech recognition engine is supposed to do a fraud, right?
mm,
And fraud detection. And this is another example which is very close to my heart. So speech recognition problem statement was this fraud problem statement was that delivery executives, they will reach the restaurant, and then they will give a call to the customer saying that their order has not been placed because of some technical issues. And in the process, now they are standing at the restaurant. Would they prefer that the delivery executive gets the order for the customer? The order which was placed to the Swiggy, when the delivery executive reaches there, they will cancel it together, and customer will pay directly to the delivery executive, right? And this is a fraud if you look at it, because delivery executive is taking the money. Now, When the order gets late beyond the period, usually the customers will get reimbursed, if they're having a good history. And all of this is something which was the fraud model which was operating. Now, this fraud model is something which is now can be solved using a pipeline. What is the first part of the pipeline? First part of the pipeline is a speech recognition engine, right? So speech recognition is converting a speech into text. There is second part of the pipeline, which is about the finding out what are the patterns which are problematic or which are related to fraud, right? Now there are two AI systems which are working, right? And these AI systems, they are dependent on each other. Think of it that without having an MLOps pipeline, I am not in a position to track. Because let's say people who are developing the ASR engine, they make certain changes, because of which the output of ASR engine, which is the text, gets changed. Right? And the NLP people are not aware of it, who are doing the pattern recognition. Their system will start performing poorly, and finally the result is poor, right? And many a times you will see that there's AI systems, the complex ones, they work in tandem. So without, and people will be working who are, let's say, some people are speech experts, some people are NLP expert, they are working in, on their system. But if MLOps is not available to them, they are not in a position to see that how the things are changing. Because one part of the system change, everything has to understand that. And this is the place where MLOps may have been used heavily in our system as well. So when the NLP system, the very first NLP system which we developed, it was more of a keyword spotting, right? So if certain keywords have been said, it's a fraud. And then, we move to the more expressive ones, that can these keywords be expanded, right? So let's say keyword is A, but what are the other words which are similar to A? And they can also be reason for the fraud or the patterns for the fraud. And then I, change my NLP system. Then I may say that I'll be using a model which is called an LSTM, which is, processing the data in a sequence. And then I say that, okay, my system is LSTM based. Now, all of this is something which is happening on the tech side. Similarly, the speech people, they are improving the performance of their system, right? They are saying that right now we are at 50% accuracy. Now we have moved to 65, or now we are 70. If these two models have to work in tandem, then all of this is needed. And then the pipeline may get more complex as well. Think of it that the keyword which is uttered by the delivery executive could be the reason for the pattern for fraud. But if I speak the same keyword, it may not be fraud. Now, you need more complex systems, right? So this kind of system where we are able to identify whether it's the delivery executive or the customer, they are known as speaker diarization, right? Now, speaker diarization. So now the three systems are working together. And without traceability and trackability of each of these systems in the combined one, we cannot do our job, right? So MLOps, and think of it now that I was saying, right, systems may change very fast. Single system of ASR is changing slow. Single system of speaker diarization is changing slow. Single system of NLP is changing slow. But all three of them being put together, they are changing fast. And then without MLP, MLOps, basically, I'm not in a position to do justice to the overall thing, right? So and obviously the data drift part, I have already mentioned that it's very important that, there it has been taken care of.
Yeah.
Yeah.
Yeah. Uh, Thank you so much, sir. That was very detailed explanation, and I
It's
do
a
love.
very detailed,
Yeah.
I'm sorry for it, but,
नहीं, नहीं, not. I'm sorry
because
about this part. It's
some
just
of those,
I
right.
love how easy you make things to understand with how many examples you have, not just like with your previous companies as well, but normally like people will be able to understand it completely, and that's the part that I really love and I'm loving about this conversation.
Right. So actually, many of these things, many a times, many people, they are working with simplistic ones.
Mm.
So let's say LLM, when people are using, let's say, a single API being called.
Yeah.
But that's not the end. That's the start.
Hmm.
And there is so much which needs to be built around it, right?
Yeah.
And then when many AI systems come together, right?
Hmm.
And nowadays they are called as agentic, right?
Hmm.
But the think of it, this agentic thing we were doing even before in some fashion.
Hmm.
Means it's not fully agentic because if you look at it, agentic says that this will be done on the fly, that LLM will be able to understand it, and then things will. We were more like we were acting like the people who will be developing the new agents,
Hmm.
looking at the problem statements, in several fashion, right? And then we will be developing our systems, which are in the beginning they will be looking like a single system, let's say ASR, with a
Hmm.
very small pattern recognition, which is
Hmm.
like keywords, and then ASR but with NLP, and then
Hmm.
ASR with speaker diarization, and then there were more things, but means the practical systems are always complex, and
Yeah.
because of that, maintenance is also equally complex.
Hmm.
MLOps is, the best way of dealing with these, basically.
So that brings me to my last question.
Mhm.
How do you balance the need for rapid experimentation with maintaining production grade stability in live AI systems?
So live AI means, Pranita, we have to see that it's a stable system.
Hmm.
Stable means it's doing what it is supposed to do.
Hmm.
Now, where the experimentation part comes in. Experimentation part is there are two things which comes into my mind. One part is there a new system which is more efficient, which can solve this problem more efficiently, which is business ROI or something. That's one thing, right?
Hmm.
The second thing is certain problem statements my current system is not able to solve. And I have to figure it out, means because I have to improve the performance of my existing system, right?
Hmm.
And unless and until I do this error analysis of my existing system, I'm not in a position. This is the place where you will be having your sandbox and you will be having your, the stable AI system which has been deployed.
Hmm.
Sandbox is the place where all this information about the newer technologies which are available, where my system is failing, um, think of it, let's say quantization experiments if it has to be done, right? Very simplistic, I'll give you an example. So we developed a system which was, the ASR system was costing 4 rupees per hour, right?
Hmm.
It's a very cheap when we are looking at, let's say, the systems which are available outside. This was
Hmm.
developed inside Swiggy, end-to-end for English,
Yeah.
right? And for food domain, and a pretty beautiful system, 70% accuracy or something.
Hmm.
We were paying the technology cost of 4 rupees, right? Pretty stable system. And now we started looking at the possibility. Where are we inefficient? And that's the place where the sandbox comes into the picture. And we started looking at the whole pipeline, and we
Hmm.
realized that, the distributed way of looking at the things will be so much superior, right? Then we also looked at this, when the data downloads or something have to be done, right?
Hmm.
Earlier, the whole system was because GPU based or something. We started breaking the system that which parts can be running on CPU.
Hmm.
And we were able to, what you say, break down the system, and then we were able to play around, and then we were able to reduce the cost to 2.5 rupees.
Hmm.
So now what, on occasion 1.5 rupees, how big is this? But think of it that if thousands and thousands of hours of data needs to be processed, right?
Hmm.
1.5, that's the multiplication factor. And this is that mindset where my stable system could be extremely good. It's doing its job. I'm pretty happy with it.
Hmm.
I'm not satisfied with it, right? And I keep looking at the system from different perspectives, right? Very simple things on occasion, perspective when we look at it. Think of it that I'm taking it little away from the problem statement. I want to get my data annotated.
Hmm.
My speech data has to be annotated. It cost me a certain amount every hour. Every hour of data will be costing me 10,000 rupees. Now I can take the bulk data and can give it to the annotators and pay them that money and
Mm.
frugality.
Yeah.
I get this data, I remove the silence part because when I and you we are speaking, right? There will be places where there'll be silence.
Yeah.
Now this silence is something if I remove it,
Mm.
I don't have to pay for it, right? Now,
Right.
it could be 15%. It's usually it has been estimated that 30% of the things when a conversation is happening,
Mm.
30% could be silence. Now, I may not be able to remove 30% because it may start cutting the speech as well if I get very close. But let's say if I'm able to remove 15% of it, right? I can do a pretty good job, let's say, for example, one thing. And my cost of annotation, instead of sending 10 hours of data and paying this much money, I may be able to send more data, which is, speech being removed and the
Mm.
annotation happening. Now, this is that frugality mindset. When I'm developing my system, this frugality is all across, Pranita. It's not about only the AI model has been deployed.
Mm.
When I'm developing my AI model, all of this starts playing out, right? And now another example, means obviously examples are more just to give the real impact to the audience, in real sense. So now this chatbot model which I was talking about, is one thing, but there are so many other models which are there.
Mm.
One model which we were developing an OCR pipeline.
Mm.
OCR pipeline for delivery executives onboarding. What was this OCR pipeline doing? You are having the documents, ID documents submitted by the delivery executives, right? This is could be your Aadhaar, it could be your PAN card, driving license. These are the three documents which are important for us to know who is this delivery executive who is onboarding. And if you really look at the problem statement, if everything is well controlled, right?
Mm.
When you ask for the PAN card is there. It has been.
Mm.
When you ask for the Aadhaar is loaded, right?
Mm.
Reality is totally different. My delivery executive does not know, nitty-gritties of the things. And he may put all the documents together and he'll take a single snap. A single photo of all the three thing pieces being put together. And I have to do justice to it. Now, my model may be very stable and running, but these problem statements will come when I do my data analysis where I'm going wrong.
Right.
And this is the place I will be developing new models.
Mm.
Now I'm having two possibility. One possibility is that I say that any document which comes, if it is I'm able to detect there are multiple documents in it, I will not process it.
Mm.
That's one decision. But what is the problem with this decision? The delivery executive has to reload a new picture, but he does not know that he cannot do this.
Mm.
He may do the same thing again,
Mm.
right? So I have to think about it. If this problem is something which is a big problem, many people are doing it, what should I do? So I'll start developing a new pipeline. What is this new pipeline about? This is about document segmentation. A single document may have more than one document.
Mm.
I had not thought of it when I was developing my initial pipeline.
Mm.
Now, this development will take in sandbox. I will stabilize this, and
Mm.
then this will become the first part
Mm.
of the pipeline. That I start understanding my documents. If my documents are of certain kind, I will let them go through the pipeline. But if the documents are something which are merged, more than one document in a single image,
Mm.
first I'll do the document segmentation. It's a separate pipeline. This document segmentation will create three documents out of one document. And then this is a start flowing, right?
Mm.
And this is that continuous development which you have to develop new systems even when your existing AI pipeline is very stable. And you develop these systems in your sandbox or you do all the things. And then you put together new systems. And
Mm.
then there is the simpler one, which I did not touch upon. that the data drift and those kind of things happen in a
Mm-hmm.
single pipeline. And then you train. I'm talking about the systems which cannot meet the problem statement the way you may have envisaged. The problem statement is, so the way you solve the problem, Parinita, in many of these things, 80-20 rule. 80% of the problem is reasonably well defined and 20% is slightly less defined. And you have
Mm-hmm.
solved this 80%. Now this 20% is left. And it could be a big problem still to be solved. Again, 80-20 may come.
Yeah.
So the way I mentioned to you, speaker diarization,
Yeah.
speech recognition, right?
Mm.
Word spoken by you versus me, they have different meaning. Similarly, in this, the documents which are getting loaded, right? Single image may have more than one document.
Yeah.
Again, I have to solve this. Now, again, 80-20. I have solved this. There could be more problems,
Mm.
right? And I have to solve it to the level where the
Mm.
business impact is good enough. Because I told you another solution is there, certain documents I may stop accepting.
Mm.
That's also a business decision if you look at it. And there is again AI playing a role. AI
Mm.
says that this document I cannot process. Now think of it that the quality of the document is very poor.
Yeah.
I may have to take a decision that, yes, here I have been able to detect and it has to be changed, right?
Mm.
So this is the place where many of the real uh, complex AI-based systems,
Mm.
they are, by their nature, they are not static. There are a lot of problems which keep emerging and you keep solving for them, and your system becomes more of a agentic kind of system where several agents are operating on this to solve the same problem which you are solving before, right? So this is how on occasion the pipelines get developed, and you keep experimenting for efficiency, for ROI, for the new problems which you may not have solved. And this is, the what makes the life extremely interesting.
Well, thank you so much, Hemant. So that was my last question, and thank you so much for agreeing for this podcast. I can't begin to tell you how much knowledge rich this podcast is, and thank you so much for giving us your precious time. I really do appreciate you doing this for us. Thank you so much.
Very happy to connect, Pranita. Means I will be so happy if youngsters, when they look at this podcast and they understand that AI is, not a simplistic single tool.
Mm.
There is so much which is under the bonnet. There are
Yeah.
so many things which are needed for making it to succeed, right?
Mm.
And how to connect all the dots, how to be engaged with the whole pipeline.
Mm.
When you start thinking that I want to develop an AI system,
Mm.
this is so much important in, when you want to become a good AI person, uh,
Mm.
an expert who has deployed.
Mm.
Right. Academia experts, their job is not this. They say they go deep down and down, and it's
Yeah.
good, means I'm very happy, right?
Yeah.
But the situation is practical AI is having more nuances.